Hello dear students and welcome to my YouTube channel. In today's video we are going to look at a previous year question paper of semester 1 at SIES Graduate School of Technology. The modules covered were matrices, complex number, hyperbolic functions and logarithms of a complex number, expansion of function, partial differentiation and its application, successive differentiation, numerical solutions of transcendental equations, systems of linear algebraic equations and curve fitting. The paper was of 80 marks, timed at 3 hours duration. We are today going to cover question number 1. Question number 1, you can see that there are 6 sub-questions, and of these 6, we need to attempt any 4, wherein each question carries 5 marks. We'll be beginning with sub-question A, which is based on the module matrices. The B sub-question is based on the second module, which is complex numbers. The third one is based on partial differentiation. The fourth one is based on successive differentiation, expansion of functions, and again complex. So let's start with question 1A. So here we are given that express the following matrix A, which is a 3 by 3 complex matrix, as P+iQ, where P and Q both are Hermitian matrices. Now here I would like to tell you one trick. If suppose you are required to express A as sum of symmetric and skew symmetric matrices, then in such cases we take help of the transpose, which is denoted by A prime or A raised to T, wherein if you are asked to express the matrices Hermitian and skew Hermitian or Hermitian and Hermitian, like in this case, then we are going to take help of the transjugate, which is denoted by A raised to theta. Transjugate, as the word suggests, it is made up of two parts, transpose and conjugate, which you can do in any order of your preference. So let's get started with the solution. So we are given A, which is this. Now here I am going to write down a detailed solution. So if you feel that it is going too slow, you can fast forward it and go ahead, or you can watch this preferably at 2x. Now once we have A, since we'll be looking out for A raised to theta, we will either have to find what is A transpose and then conjugate it, or we can take the conjugate first and then transpose it. So let us take A transpose first. So as the rule, you know that A transpose means the columns are going to be exchanged with the rows. So we get the resultant matrix. And lastly, A raised to theta, which is going to be the complex conjugate of A transpose. So the last matrix that we have obtained, we are going to take the complex conjugate of each of the entries in that matrix. So we will have a negative I, 1 minus 2i, and so on. So this is what we have. Now, as a practice, we are going to take the sum of these two matrices, and also later on we will be taking the difference of both the matrix. So let us talk about the sum of A, which is here, and A raised to theta, which is this. And we know that the addition of matrices happens correspondingly. So we will be beginning with the A11 entry, and that gives us 2 plus 2, which is 4. The next one, we'll be having 3 minus I and plus minus I, which will give us 3 minus 2i. And continuing so on, we get this. And also simultaneously, let us talk about the difference of this. So here we have got a plus a raised to theta and a minus a raised to theta. Now going back, we need to write down a as p plus I into q, where p and q both are Hermitian matrices. So we have got two new matrices. We are going to check whether these are Hermitian. Now prior to that, we are also going to at the same time take a factor of half and a plus a raised to theta. Okay, so I'll not multiply the half, I'll keep the half outside. And let us declare this matrix as P. So we have got P is equal to half of A plus A raised to theta. And now since we want P to be Hermitian, the definition of Hermitian matrix is that a matrix A is said to be Hermitian if A transjugate is equal to A. So in this case, we wanted to check what is P raised to theta, and since P needs to be Hermitian, the outcome is going to be P again. So we will not be taking the matrix again and doing the things. We just plug the values over here. So when you take the transjugate, this is going to be half, and this will become a raised to theta plus a raised to theta doubled. So this is going to be a raised to theta, and that is nothing but half a raised to theta plus a. And since we know that the addition of matrices is commutative, so we get that therefore P raised to theta is equal to P, which gives us that P is a Hermitian matrix. Now likewise, we will be checking about A minus A raised to theta. So over here, if we have a closer look that A minus A raised to theta, if we take the transjugate, then it is not going to come back as A minus A raised to theta. So whenever you will have a problem like this, you see that you have a factor of I attached to Q. So we are going to declare Q as 1 over 2i times of A minus A raised to theta. And this is going to be 1 by 2i into the matrix, which is this. And again the same thing, we got to check whether Q is Hermitian. So we will be getting that Q raised to theta is going to be the transjugate of 1 by 2i A minus A raised to theta, the transjugate of this. Now since you are going to take the transjugate, 1 by 2i will become negative 1 by 2i, and here we will have A raised to theta minus E raised to theta twice, so this is going to become A, and then we can adjust the negative sign within, and we will be getting back 1 by 2i times A minus A raised to theta, which is nothing but Q again. So we get that Q raised to theta is same as Q, and therefore we can say that Q is also a Hermitian matrix. Now for the next part, we are only left out to write down the expression. So we will be saying that consider P plus IQ. So we have already written what P is. So P is half, and then here we have the matrix A plus A raised to theta. And then we have I into Q, and Q we have said that it is 1 over 2i into A minus A raised to theta, which is this matrix over here. And if you will work on this, you will be getting the matrix A. I'll just show you the first row calculations. So also you can realize that the I can be getting off. So we'll be getting 2 plus 0. So that's going to be 2 in the first entry of the first row. Then here we have 3 minus 2i plus 3. So that is going to be 6 minus 2i, which when divided by 2 becomes 3 minus I. Moving on to the next entry. So we have got 3. So this is going to be 2 and then plus 2i. So that's going to be. So if we'll compare this with the first row of the matrix A, so we are getting the same. See, it is 2, 3 minus I and 2 plus I, which we are getting. And likewise, you can complete the other entries. Let me quickly complete the other entries as well. So we have got I, 0, 1 minus I. And then the last row, we have got 1 plus 2i, 1 and 3i. And we can say that therefore, P plus iq is equal to A, or A is equal to P plus iq, where P and Q are Hermitian matrices. So with this, we complete the first 5 marks of the question paper. Let's tackle question 1b. So here we are given 6 sine hyperbolic of x plus 2 cos hyperbolic of x plus 7 is equal to 0. And we are asked to find out the value of tan hyperbolic of x. So we'll be starting with the given expression. So we say that given 6 into sine hyperbolic of x plus 2 into cos hyperbolic of x plus 7 equals 0. And simultaneously, I'll just write down the expression for tan hyperbolic of x. So tan hyperbolic of x is given like this: e raised to x minus e raised to negative x divided by e raised to x plus e raised to negative x. If we work on the simplification of the negative exponent, we will be getting e raised to minus 1 over e raised to x divided by e raised to x plus 1 over e raised to x, which gives us e raised to 2x minus 1 over e raised to 2x plus 1. So this is the simplest expression of tan hyperbolic of x, which we will be trying to figure out. So coming back on the given part, 6 sine hyperbolic of x, applying the definition of hyperbolic sine hyperbolic, we are going to get this to be 6 into e raised to x minus e raised to negative x divided by 2 and plus 2 times cos hyperbolic x is e raised to x plus e raised to negative x over 2 and plus 7 is equal to 0. So we can get rid of the 2 factor in the denominator. So we will be having 3 raised to x minus 3 raised to negative x plus e raised to x plus e raised to minus x plus 7 is equal to 0. We have got some like terms, so let's collect them. So we have got 4 e raised to x minus 2 e raised to negative x plus 7 is equal to 0. Again, the negative exponent can be written as the reciprocal of e raised to x, which will give us 4 e raised to 2x minus 2 plus 7 e raised to x equal to 0. So this can be simply written as 4 e raised to x whole square plus 7 e raised to x minus 2 is equal to 0. And this equation which we have got, it is a quadratic equation. In e raised to x. So it looks simpler to factorize this. So we can rewrite this as 4 e raised to x whole square plus 8 e raised to x minus 1 e raised to x minus 2 is equal to 0. And factoring out 4 e raised to x from here, we get e raised to x plus 2. And from this, we can factor out negative 1. So we will be having e raised to x plus 2 is equal to 0. And this gives us e raised to x plus 2 into 4 e raised to x minus 1 is equal to 0. And thus we get e raised to x plus 2 equals 0 and 4 e raised to x minus 1 equals 0. which gives us e raised to x is equal to -2 and e raised to x is equal to 1 over 4. Now since you see that there are two values of e raised to x, so we are going to get two values of the tan hyperbolic function as well. Now if we'll just come back over here, this is nothing but e raised to x square minus 1 and divided by e raised to x whole square plus 1. So let us assume the value of e raised to x as -2 first. So when we do this, the value of tan hyperbolic of x is going to be, we'll directly substitute it in this expression and we get -2 squared minus 1 over -2 squared plus 1, which is going to be 3 over 5. And if e raised to x is taking the value 1 over 4, then in that case the value of tan hyperbolic of x is going to be 1 over 4 square minus 1 divided by 1 over 4 squared plus 1. And on simplification, this gives us 1 minus 16 over 1 plus 16, which is equal to -15 over 70. So this is another value of tan hyperbolic of x. Now let's move on to question 1c. This question is based on partial differentiation and its application module. So over here you can see that the function u is expressed as function of ax minus by, by minus cz and cz minus ax. And we are looking out to prove that this expression in terms of involving partial differentiation of u with respect to x, y and z variable is equal to 0. So over here we take help of some intermediate variables. What we will be doing is we are first going to redefine these three terms as, say, capital X, Y and capital Z. So we'll start with the solution saying that let capital X is equal to ax minus by, capital Y is equal to by minus cz and capital Z is equal to cz minus ax. Just a word of caution, try to differentiate your capital Z and small z very clearly. So we have got this, so therefore we can say that therefore u becomes a function of x, capital Y and capital Z. Now we'll be taking help of something known as lattice, which helps us understand the relationship between the function and the intermediate variables as well as the independent variables. So for that, we'll be starting with the function which is denoted by u. Now we can see that u has been expressed as a function of x, y and z variables, capital letters. So from u we are going to drop down three arrows. So one for x, one for y and one for z, and we are going to put it downwards like this. This indicates the dependency of function u. Now further, if you will have a look at x, capital X, it depends on the variable x and y, small x and small y. So we will be writing x and y at the third level, and again we'll be dropping arrows from capital X indicating the dependency of capital X on these two variables. Likewise, capital Y depends on the variables y and z, small y and small z. So we already have small y over here, and then let us also introduce small z. So I've just put a break in z to differentiate capital Z and small z. And lastly, capital Z depends on z and x variables. So from z, capital Z, we are going to have drop downs on small z and small x. So this is what you have, the lattice. Now the lattice structure helps us in writing down the partial differentiation very nicely without making any mistakes. So let's talk about the partial differentiation of u with respect to x, which is the first term of the required left hand side. So del u by del x. So for this, what we will be doing is we look at the starting point as u and the end point as x. Now you can see that from u to reach till x, you have one path which is this. You can go to capital X and then come to small x. Let us just write it down here. So from u, I can go to capital X and then I can come down to capital small x. And likewise, you can see that there is another path which is from capital Z to x. So the other path is from u, you can traverse all the way to capital Z and then come down to x. So these are the two paths which are available, and these two paths help us in writing down the differentiation of u with respect to x partially. So it is going to be del u by del capital X, which comes from this, and then del x with respect to del x small x, and then the other one is del u with respect to del z, and then del z with respect to del x. Likewise, del u with respect to del y is going to be del u over del capital X over del y, plus del u over del capital Y del capital Y over del y. And lastly, del u over del z. This is going to be del u over del capital Y over del z, plus del u over del capital Z and del capital Z over del z. So these are the expressions that we have. Now we'll step by step start constructing the left hand side. So therefore 1 over alpha del u by del x plus 1 over beta del u by del y plus 1 over, I'm sorry, it is not beta, it is b, 1 over c del u by del z. This is going to be 1 over a. Now let's focus on this term which is available to us in this manner. So the first expression is del u by del x. So let us write down del u by del x. Now we are not in a position to differentiate del u by del x because as you can see that there is no explicit definition which is provided to us. So we just know that u is a function f of x, y and z. We don't know what it is explicitly. So we won't be able to differentiate it. So that comes down as it is. So this is going to be del u by del capital X. And then the next term which is there, this is del x by del capital X over x. So that we can differentiate. So if you will have a look of capital X, it is expressed as ax minus by. So let me just write it here. So capital X is expressed as ax minus by. So therefore I can talk about the partial differentiation of this with x variable, and that is going to be a alone, since the partial derivative of by is going to become 0. So this is going to be into a. And then we have del u by del capital Z. So again del u by del capital Z has no expression, and then del capital Z by del Z. So for this we are going to use this expression, and that is going to give us negative, and this everything is multiplied by 1 over 2. Now likewise for the second term we have 1 by b factor out, and then del u by del x remains as it is. For del x with respect to del y, we will be having negative b, and then plus del u over del capital Y, and then del capital Y over y is going to give us b. And then the third term 1 by c, del u by del y stays as it is. Then we need del y by del z, which is going to be negative c, and then plus del u by del z into del z over del z, which is going to be plus c. Now let us simplify this expression. So in the first term we can see that we have a factor of a which can be taken common, and that cancels by 1 over a outside the bracket. So we will be having del u over del capital X minus del u over del capital Z to be remaining from the first term. Likewise from the second term we can see that we have a factor of b which gets away with 1 over b, So we will be having minus del u by del x, and then followed by plus del u by del capital Y. And likewise from the last term we will be having negative del u by del capital Y plus del u over del capital Z. And we have cancellations happening here, so del u by del x goes away with this, then del u over del capital Z goes away with this, and lastly del u over del capital Y goes away. So we are left out with eventually 0, and that concludes with the proof. So with this we are done with 3 questions from question number 1 carrying a weightage of 15 marks. I hope you have understood what I've tried to convey. So practice more and more problems and give your best. I'll be subsequently uploading more videos dealing with the same question paper. If you have not yet subscribed to my channel, please do consider subscribing my channel.